All right. Hi, everybody. I'm Shea from Flashbots, and I am very excited to be here at Permissionless today. I want to talk with you all about what it actually looks like to build permissionless markets. What's under the hood, what's actually powering all of the DeFi apps and protocols and chains and tokens that we're familiar with. Because I think that ultimately the design of those underlying markets of what we call MEV is one of the most important challenges in crypto today. I'm going to tell you why I think MEV is at the heart of creating great crypto apps, but why it's so hard to actually make MEV permissionless, and some ideas for how to fix those problems. I'm going to focus today on Ethereum, but I do think these kind of lessons are applicable more broadly. Okay, starting with the basics. Probably the most popular thing to do in crypto is click this button, the swap button, exchanging one asset for another. And it looks very simple, but what actually happens when you do this, what goes into getting a good price? Under the hood, it actually looks like this. Under the hood of DeFi is an economy of bots, tons of different actors that help with routing and merging and landing your trade on chain. And there's actually a lot of money changing hands here. There are incentives that apps and users play all these actors to perform useful tasks, maybe without even realizing it. And that's called MEV, or maximum extractable value, these incentives. There's also money flowing upstream in the form of either explicit refunds or just better prices that this market produces for your trades. And you probably have no idea that all of this is happening, but it is. And I want to look at just a few places where this MEV supply chain actually impacts the outcomes that you get on chain. Starting with your wallet. When you create a transaction in your wallet, you might think that it actually gets propagated to the whole public mempool, to the whole network, but actually most transactions on Ethereum today are not seen in the public mempool, and they haven't been for years. Because under the hood, every major wallet on Ethereum is actually auctioning off your transactions privately to improve your execution. So, for example, if you make a large trade, you will often create an arbitrage between the pool you traded on and the price on other domains. This has become very popular for wallets to send your transactions to what we call an order flow auction, which lets a market of MEV bots permissionlessly compete to backrun you, capture that MEV, that arbitrage, and then split the profits with you. And these are a few popular examples of order flow auctions. I personally think that order flow auctions are a really cool mechanism that could help improve the way retail flow is processed in finance. So instead of your favorite trading app sort of making a deal, a payment for order flow deal to sell your flow to Citadel every quarter, we can have a permissionless market with hundreds of bots, as you can kind of see in the fine print here, that compete to optimize the execution of every transaction. But to work well, this market needs a lot of competition. We want it to be permissionless for any bot to compete, and otherwise we've kind of just recreated the current PFOF market structure with more complexity and different names for Citadel. So that's wallets, but I think there's more. So good MEV markets are actually really important for making good trading apps. So one of the major trends in DeFi recently, which I think the panel before was touching on a little bit, is towards app-specific sequencing, where apps kind of try to take more control of how their users get executed in order to give them better outcomes. So example, a lot of the innovation in DEXs today, like CowSwap or Uniswap X, has been to outsource the execution of a trade to a sophisticated market of parties that we call solvers or fillers, who can solve this very hard problem of finding the next route or the best route. And what this basically means is that your favorite trading apps are increasingly relying on these external MEV markets to get you good execution. So the design of those markets is more and more important. And it also goes beyond trading. So good MEV markets are at the core of other DeFi protocols like lending. One of the most important things that lending protocols really need to do is to keep the collateral ratio in balance. So they offer a permissionless bribe, i.e. MEV, to bots who will come and remove bad debt by liquidating under-collateralized loans. And again, that nature of that MEV market, how many bots there are, how good they are at sourcing liquidity is hugely important to making the lending protocol work. TLDR, permissionless MEV markets, are essential to making DeFi work. They're behind everything from the health of your lending protocol to the price that you get on a trade. And I would argue that getting permissionlessness right in MEV is essential to making DeFi a genuine improvement over traditional finance. If long-tail liquidation bots can compete on Aave, then it might be difficult to kind of offer full coverage and reliability that you actually really want to support meaningful financial flows on chain. Likewise, if your order flow auctions are permissioned, we haven't really made something 10 times better than PFOF. We've just recreated Citadel with another name. So it's all about MEV. Okay, so how well are we doing? Well, I think we're pretty far from where we want to be. In fact, the trend in recent years has been towards higher barriers to entry and more consolidation of power in key points of the MEV supply chain. Personally, I think this is both because of the fundamental technical choices that, in how we build these markets, but also because of the choices that you and I are making, that protocol designers, applications, and end users are making with how they route their trades. And I kind of want to talk about both of those classes of problems. First of all, why is it technically so hard to create good permissionless markets in MEV? Well, there are a few specific constraints that we have to work around. First is privacy. In MEV, information has financial value. So if someone knows you're about to make a trade, they can front run you to make a profit and give you a worse price. But very famously, public blockchains, not private. So we need to develop fundamentally new infrastructure to provide these sort of protections in MEV markets. The second challenge, I think, is handling scaling and spam. So if you put free money on the internet, people are going to spam you for it because it can be worth it for bots to pay for hundreds of failed transactions just if they can land one that captures a really juicy opportunity. Unfortunately, what this means is that if your MEV markets, if all this competition is resolved on-chain, those failed transactions end up eating tons of resources on your blockchain. So we've seen this historically on Ethereum L1. It's actually one of the inspirations for the founding of Flashbots. And today, spam transactions are from MEV bots account for something like half of the gas on top Ethereum rollups. Bots are actually guzzling, we looked at it, 650 times more resources than they actually need to execute a successful arbitrage. And if you haven't seen it, there are some great analyses on the Flashbots website about this. Lots of more juicy charts, so take a look at them. But kind of in the interest of time, I will skip to the TLDR, which is that if we want efficient, permissionless MEV markets, we have to run them off-chain. Where we can get privacy and handle the insane amount of load from things like spam. And this begs, in my view, a very important question, which is, how do you make sure those off-chain markets follow the rules? Especially when they're permissionless with lots of potentially hostile participants, like we saw in that sort of sand key diagram at the start. If they aren't governed by smart contracts, if actually all of the activity is private, how do you know that these external markets you're outsourcing very key parts of your application to are respecting the rules? Well, I would argue that basically modern crypto apps don't yet have a good solution to this problem. Take CowSwap just as one example. This is no shade to CowSwap. CowSwap is a very cool DEX that uses application-specific sequencing to sort of outsource execution to a market of solvers, give users better prices. But the problem is that it's really hard to do that outsourcing without introducing new permissions. So today, CowSwap solvers have to stake $500,000 just to participate in the auction. And those capital requirements, unfortunately, limit participation. Even if anyone can join in theory, in practice, only people with $500,000 can play the game. Another sort of solution is social contracts trust. So in MEV Share, MEV Share, the auction that we run at Flashbots, we rely on parties that we call block builders to actually execute those refunds that pay users back for their MEV. And to make sure they actually do this and follow the rules, we basically just go around and ask every block builder, hey, can you commit to the rules in this screenshot? And they literally submit a PR to an open source repo, and then I go and approve it. That's how it works. But surprise, surprise, social contracts can be broken. So these are just a few anonymized screenshots from my DMs, where basically block builders were either intentionally including the wrong refunds or just misinterpreting the rules. TLDR, pinky promises, pretty suboptimal way to enforce good behavior in off-chain MEV markets. Unfortunately, because this stuff is hard, a lot of projects just give up on permissionlessness entirely. These are a few examples from the docs of some popular backrunning products that basically explicitly require MEV searchers to register and get permission to participate in their auction. Okay, so how do we go from these trust-based, capital-intensive solutions to verifiable, confidential, off-chain infrastructure for MEV? I think this is a trillion-dollar question for crypto, and not having a good answer has stalled progress a lot, not just in MEV, but also in DeFi more broadly over the last few years. There we go. Okay, but it's not just a technical problem. The shape of the MEV supply chain also depends on us, on you, on me, on the apps and wallets that are generating what we call order flow. And to illustrate why this matters, I want to tell you a little story. There we go. Over the last 2 years, monetizing order flow has been one of the biggest metas on Ethereum. So wallets and apps generate tons of value in the form of the priority fees that their users pay to land transactions on chain, and they really want to monetize this. And this created what we call the order flow wars, where wallets and apps made private deals to exclusively send their order flow to certain actors in the MEV supply chain, who sort of promised to recapture some of the value that they were previously just yeeting away. In particular, just to kind of explain how this works, people were making deals with a very specific actor that we call a block builder. Block building refers to just the process for how transactions get sequenced into a block. So who lands on chain, in what order, when. And on Ethereum, most validators actually outsource this job to a sophisticated external party that we call a block builder that's able to build much more valuable blocks than the default client. And there are sort of many builders that will compete to provide the best block. But coming back to this, what the order flow wars did is they created a bunch of exclusive deals where certain block builders would have access to order flow that others didn't. And a big problem with this, going back to the theme, is permissionlessness. So these deals were opaque and not available to everybody, not all order flow providers, not all block builders. And a sort of classic example here that I've been flashing on the screen is the deal between Banana Gun, a top Telegram bot, and Titan Builder. So Banana Gun, to this day, sends exclusive order flow to Titan in exchange for preferential treatment and refunds. But this deal and the order flow wars more broadly are notable because they massively centralize the block building market on Ethereum. So at the start of this year, there were 2 teams that were basically building, sequencing 90% of Ethereum blocks. And this is clearly very risky. You don't want a single team to be in charge of sequencing all the order flow in crypto. They could just unilaterally censor or manipulate the way that things settle on chain. These permissioned deals also have very real negative externalities for users. So one problem is that the order flow wars made it really hard for new parties to enter the market because they had to do a lot of BD and sort of pay to play. And this prevented, I know, a number of great teams from actually joining the space and innovating on new software. It also meant that existing teams had to spend all of their time on these like boilerplate things, on BD, and much less of their time executing on implementing new features for users. Another problem is that because exclusive order flow deals were kind of opaque and discoordinated with each other, builders often ended up competing against each other in ways that actually gave users worse outcomes. So there's a very funny cycle here where basically builders would overpay to land more blocks because that would help them qualify for access to more order flow. But because they raised their bids, they actually drove the cost of inclusion higher for users. So both people were basically worse off. Okay, so I think the other trillion-dollar question here is, how do we help order flow providers capture their value permissionlessly instead of forcing everybody to make these handshake deals, which are kind of cumbersome for both sides? I think we basically need a protocol that makes it very simple for everyone to just capture the MEV that they're creating on chain. This way, all order flow providers can benefit, and MEV teams, builders, searchers, whoever, can just innovate on building better software rather than fighting this really annoying zero-sum game. Maybe put another way, we need permissionless redistribution in addition to verifiable, confidential, off-chain compute to create this sort of permissionless MEV markets that crypto so deeply depends on. Okay, fortunately, I think there's some hope here. So I want to share, to close, a path forward that we've been working on at Flashbots and with many other teams in the MEV space. First of all, we think that solving the trillion-dollar questions starts with new technology. So we need fundamentally new tech, actually new hardware for MEV that will keep your data private, that will enforce constraints around behavior, and will do all of this without you having to trust somebody. Also, we need this infrastructure to be really, really fast, so high-frequency trading levels of fast. And we think there is hardware that can meet all of these requirements. So a type of machine that we call trusted execution environments, or TEEs for short. Basically, if you're not familiar, TEEs give you a machine attestation that specifies exactly what software somebody is running. And they also prevent whoever is running this machine, this TEE, from peeking at the sensitive data inside of it. So this basically is really cool because it lets you run verifiable, confidential, off-chain infrastructure on untrusted machines. You don't have to rely on capital requirements or allow lists to gate access to your system. You can just remotely verify that people are following the rules. And over the last year, we've actually had great success in applying these TEEs for production MEV use cases. We've created a network of TEEs that is optimized for running off-chain MEV infrastructure like block builders, solvers, searchers, order flow auctions with much better guarantees. We call it BuilderNet. It's a verifiable, private, and very, very, very fast platform for off-chain MEV infrastructure. And I kind of want to just show you some of the things that it can do. With BuilderNet, we are building 25% of Ethereum L1 blocks in TEEs today. This was actually 2% a month ago, so it's growing very quickly. And we're really excited about this. We're really excited about the potential for BuilderNet to upgrade block building on Ethereum. And there are a few things that I think make it really special. First of all, you will notice that there are multiple teams running nodes inside of BuilderNet. Unlike legacy block builders that are operated by just a single team, we can let many teams run TEEs inside this network and just have them attest that they're running the correct code. You don't have to trust them. In practice, BuilderNet has 3 operators today, kind of in that nested structure: Flashbots, Nethermind, the client team, and BeaverBuild, one of the top searching and building firms on Ethereum. And this model, I think, has a few advantages over the status quo. So with multiple operators, BuilderNet is much more robust against faults. You know, if Nethermind's node goes down, BuilderNet will still build blocks. Our ultimate aim is actually to make it fully permissionless for anyone to operate a node, which would kind of remove the central points of failure that exist in the supply chain today. BuilderNet, second of all, is also more resilient to censorship. Because nodes can customize their compliance policy, which means that even if you have one builder, one team that is filtering out transactions according to a certain jurisdiction's compliance needs, another operator can actually still include them. And part of what makes this work and what makes BuilderNet really cool is what we call order flow sharing. All the nodes in BuilderNet share the transactions they see with all other nodes in the network. This was completely impossible to do safely before because sharing order flow with untrusted parties, as we know, exposes users to front running. But TEEs solve this, and it creates a very cool virtuous cycle. So sharing order flow reduces the startup cost to running a builder because you don't have to make deals anymore. You just kind of spin up a node. And that, in turn, increases participation in block building, which drives more innovation on the core software instead of teams kind of like fighting to get access to order flow. And that produces better markets that are more attractive to users, which increases the overall pie of order flow. Nice cycle. Finally, there's one other very special property of BuilderNet, which is that it enshrines a permissionless refund rule. So everyone that sends order flow to BuilderNet automatically gets paid back for the value we calculate they contributed to the blocks. So instead of these sort of approximate, fragmented handshake deals, we've created a protocol level rule that just neutralizes exclusive order flow deals completely. And so far, BuilderNet has refunded about $1 million to users in the early innings. Ultimately, as BuilderNet grows, we actually expect it to upgrade the whole Ethereum gas market to be second price, which is very cool if you're not familiar with auction design. Basically, this just means it will be a lot cheaper and a lot easier for everybody to bid for inclusion on-chain, which actually is a really big pain point that everyone from traders to wallets has today. But this is actually also just the tip of the iceberg. Many parts of the supply chain that we rely on in DeFi need infrastructure like this. So L1 builders, L2 sequencers, solvers, fillers, searchers, order flow auctions, non-Ethereum chains. With BuilderNet, we can basically create a platform for apps to get better execution and sequencing through these permissionless MEV markets. And we're working very hard to both harden it and also expand it to new frontiers. So we're bringing verifiable resilient sequencing to Ethereum rollups. As of today, all the blocks on Unichain, the new L2 from Uniswap, are built in TEEs. We're also onboarding MEV searchers and solvers to run in TEEs. We kind of figured out a way to let bots run completely private code on completely private user data without either of them revealing information to the other, which can actually, turns out, drive pretty significant price improvement in things like order flow auctions and block building. And the first TE searches have already captured a portion of the atomic arbitrage market on L1, and we're really excited to use them to upgrade kind of the core block building process in BuilderNet, amongst other things. And there's a lot more here. We're working very hard to make this platform secure, scalable, fault-tolerant, censorship-resistant, and programmable. So there are more if you want to look at it. But ultimately, we hope that platforms like BuilderNet will kind of grow this permissionless MEV economy so it can drive more innovation, more competition, and more cooperation without these barriers of trust and exclusivity that really limit crypto markets today. This technology is ready. We are not just in theory, but in practice, using TEEs, using BuilderNet to drive measurably better execution for a large percentage of Ethereum users today. But candidly, we're still very far from where we want to go. The default is still permissioned. We need to, I think, actively accelerate adoption of these new technologies to change this. It's not just going to happen on its own. The choices that apps make, the choices that you and I make actually really impact what happens here. So please come and join us.